Lesson 1.3 is primarily about applying definitions to different situations, and the definitions that we're looking at are those that refer to how to collect sample data. So we're looking at collecting the sample data, and it's just worthwhile to remind you that if you don't collect the data correctly, and even if it's not you personally, if the people that are trying to give you information did not collect the data, well, then it's meaningless. It does not mean anything. It's just something they're using to try to convince you. So if you want to have real information, you have to collect the data correctly. And if someone is trying to give you information, you should stop and consider, how did they collect the data and did they do it well? This is a listing, and the following slides kind of break down more information about each one of these, so I wouldn't try to write all of these down right now, but these are the ones that we're going to look at. Now, I have this one, simple random sample, really large and in yellow, because this is the one that within this course we will most often deal with. Sometimes they tell you about the other ones and they tell you information came from something. And in today's lesson, they'll give you some situations and ask you which one of these types of sampling methods is being used. So for today's lesson particularly, we will deal with all of them. But for most of the course, as our little note down here in blue says, most of the course will start off by saying a simple random sample was collected. Da, 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 da. So most of the time we're not actually doing the statistical collection. We are looking at the data after it comes in, and they will just tell us that it was a simple random sample. But today we learn what the methods are and what each of these labels for them means. So first of all, experiment. Unlike it sounds, an experiment does not have to be some sort of a mad scientist thing. It just means that, and it says this, a treatment is applied. So if you do something and then try to measure the results or observe the results, that's an experiment. You're just seeing what the response is to the treatment, okay? And treatment is not necessarily medical. The individuals, whether or not they're people, but whatever you're applying the treatment to, are called experimental units. And if those experimental units are people, then we generally just call them subjects, the subjects in the study, or the individuals in the study. But if it's an experimental unit, think about perhaps in an actual lab, if you wanted to maybe take some sort of bacteria in petri dishes and then put something in each dish and measure the results, well, then each one of those dishes would become an experimental unit. Now, experiments with both placebo and treatment groups, now that's particularly used for people involved. Experiments with both placebo and treatment groups determined with randomizations are the most effective when you are dealing with people. And we're going to talk about the placebo and treatment groups, but sometimes you just cannot do that. Sometimes there's too many risks involved and it's just not safe. Sometimes you don't have the money or the time it would take to measure something, and so there may be some other types of experiments. But when possible, if you're dealing with people, what you really want to deal with is a group that is getting the actual treatment and then the group that is getting a placebo, and we'll talk a little bit more about that in another slide or two. This lesson's not too long. So that was experiment, just what it is. In an observational study, you don't apply any treatment. No attempt is made to modify the outcome. So you're not doing anything but just watching and writing it down. And we mentioned a study about hand washing in the public restrooms earlier. And so just there, if you're going to make an observational study, what you really need to do is be discreet. You need to be making observations without the subjects knowing that you are observing them. And again, this is dealing with people because the petri dish doesn't know if you're making an observation. But if you're standing in a restroom, that becomes a little bit odd. I did hear of some college students who did some sort of a study about it, and they actually did a study about people washing their hands in the college restroom. And what they did is there was a group of people doing the study. They went in and only stayed a few minutes at a time and counted and then went out and sent someone else in. So there was a rotation of people that were making the observations, so they were less obvious, and actually found out that It was an unfortunately low percentage that washed their hands. So results of observational studies are likely to be skewed, that means messed up or pulled one way or another, by lurking variables than those of experiments. In other words, in an experiment, you can control a lot. But if you're doing an observational study, there could be something totally unexpected that you're not really measuring, and yet it affects the outcome of the experiment. So it's not included in the study. A lurking variable is not included in the study, but somehow it had a big effect, or it could have had an effect on it. And so if you think about that, if you're just doing an observational study and you wanted to watch these people washing their hands, it's certainly a lurking variable. If you're not doing anything to modify the outcome, then a lurking variable in a public restroom is possibly whether or not the soap dispenser has any soap in it. Does the soap dispenser work? Or what sort of hand drying equipment they have. So there's just some different, do they have things where it's touchless, or does it have to be touched? Those are things that you would not be controlling in an observational study, but that could be a lurking variable. They could have some sort of an effect. When you have an observational study, there are kind of different types, and we have these kind of categorized by time. If you're trying to figure out which type of observational study it is, and you will need this in doing your homework, look at the time when the observations happened or will happen. Retrospective is past. It's looking back. It's retro. Prospective is future. And then cross-sectional, this is one that the name doesn't quite sound like it, but cross-sectional is just measured at one particular point. The other ones are over a period of time. So retrospective is saying over the past 30 years. Prospective is over the next 30 years. Cross-sectional data are the people reporting today, maybe, or it's one particular point in time. It could be in the past, but it can't be over a past period of time. It could be cross-section of data from 1987, not from 1987 through 1990. If it's over a period of time, it's retrospective. Cross-sectional data, one point in time. Prospective is going forward in time. Now, if you're going to design an experiment, so kind of talking about, we've moved from just what there are, but designing experiments, you have to be able to have replication, blinding, and randomization. So I've got 3 slides for this, just so I wouldn't have so many words on each individual slide. But the very first one is replication. Did this just happen once? If it only happened once, it's really not a very good experiment. You need to be able to say it happened again and again and again, particularly on an experiment. In other words, I did this to this group of people and this was their response, but it wasn't just this group. It was over and over and over. The experiment must be repeated to show that the results are consistent. You want the results to be consistently repeated when you repeat the study. And the sample size should be large enough to show the effects of the experiment clearly. If you only do one sort of experiment, that is not good. I know that without looking at the big features at all of COVID-19, at one point in time, a gentleman I know was talking about how the gaiters that you pull up from the neck possibly did more harm than good. And I looked up the exact study that he referenced, and the study itself only involved one gaiter and one person, because that's not what they were testing. They were actually testing which type of mask had which type of spray come forth from it. And so they were simply measuring the type of spray and the particles involved. They would have to actually say that gaiters didn't work. They would have to use all kinds of fabric and lots of people and do it over and over and over. So not to say that you could not do a study like that, but just because somebody says it, if it hasn't been repeated or replicated or isn't something you can repeat or replicate, then it's not worthwhile. Blinding. When you are blinding, of course, we're not really talking about physical eyesight, but we're saying the subject does not know whether or not they're getting the treatment or placebo, because this can help avoid the placebo effect. So the placebo effect is in italics there. You may very well know what that means, but that means when you maybe think you got a treatment, so you just feel differently. Suppose that you think you are getting a medication for something, and so you just start to say you feel better because your attitude actually does have an effect. But that attitude and the effect it has comes into play with that placebo effect. You feel better, or if it was a negative experiment, maybe you feel worse because you just think that you've been given something to make you feel that way, and the mind is powerful. Now, double blinding, it means that neither the individuals administering the experiment nor the subjects know which one is which. So maybe something's just labeled like, I gave you capsule A, but I don't know if capsule A is a treatment or a placebo because they look exactly like the other ones. And then you took it and you don't know either. That's double blinding. So it has to be repeated a lot. If people don't know which way they're getting it, that's an important part of an experiment. And randomization can get actually very technical. Individuals are assigned to different groups by randomization so that you end up with groups that are going to reflect the population you're studying. You cannot let people just volunteer to be in a group, because if they are in a group and they all volunteer, then they're all friends, which means they probably share a lot of things and they're not a good reflection of the population. So there's a lot that goes into this process, and we can talk more about that a little bit later. But randomization is done so that the groups reflect the population. Now, this particular one is just an example, and it's the Salk vaccine experiment was really like one of the big science experiments, and I know for many of you, or for everyone in the class possibly, this is well earlier than you. But 1954, thousands of kids were getting polio, and it was causing many of them to be crippled. So it's kind of a scary thing when you're going to look at, you've got 400,000 children. You don't want to just test on, I mean, that was a scary thing for everybody at the time. But 400,000 means that they were replicating the results over and over and over, because they did not just do it on a small group. They also randomly assigned the kids to different groups. And one of the groups was given the treatment, as in the Salk vaccine, and the other one was just given an injection. Unfortunately for the kids, they got a shot, but they didn't get any medicine. Neither the people giving the shots nor the children knew which one they were getting. So it was a double-blind study. Now, out of that 400,000 children, 115 children who got the placebo later developed not just polio, but paralytic polio. They became paralyzed from polio. You would know immediately that that was practically significant to you. You can see just how much it cut down the numbers of children that were going to become paralyzed. So that was an experiment with replication, randomization, and double blinding. Simple random sample. So now let me just back up for just a moment to this slide. We've talked about an experiment, and we've talked about an observational study. We're going to look at a simple random sample, and then we'll go into that last slide with this particular amount. So a simple random sample that has to have a couple of particular features of it. And again, for most of this course, we'll have a requirement that just says at the beginning, in a simple random sample. Today you've got more going on than that, but most of the course will have a simple random sample. So what does that mean? You have N subjects, so there's some number of subjects, but they're selected in such a way that every possible sample of the same size N if I had 100 subjects that I needed to group off into groups of 25, I can't just say, here's the first 25, the next 25, and the next 25. There's nothing random about that. What you need to do is choose the groupings in some way that there's no way to know which 25 would end up together. Every group of 25, and there's just so many, that you could make out of 100, you would have the same chance of being selected. So even if you don't quite understand it right now, you need to make sure you understand that when you take 25 subjects that you're going to select out of your population, and I had 100 people, but out of that 25 subjects, then out of my 100, every possible sample of 25 would have the same chance of being selected for the study. You could not tell ahead of time who's going to be in the study. Equal chance. A random sample is not exactly the same as a simple random sample. It's very similar. But a random sample says each individual has the same chance of being selected. So instead of the group of 25 having the same chance, it is the individual that has the same chance of being selected. At this point in time, I would expect that that's not very clear to you, so if you're confused, just know that you're probably still on track, but some of what you need to do is learn those definitions, and it will make more sense as we go along. So for a simple random sample, it's the sample of the same size that has an equal chance. With only a random sample, it's the individual that has an equal chance of being selected. For most of the course, we'll have the simple random sample. Okay, now there are other sampling methods besides observation and experiments. One more time, back up to this slide. We've talked about experiments and observational studies. Most of what we will do will be from simple random samples. And if you think about it, within a class like this, we don't really have the opportunity or means to do experiments. And it's not practical for us to do a lot of observational studies. So what we're going to do is take data from some different things where this has already been collected, and we will be using data collected from simple random samples for the most part. But there are other methods: the systematic, convenient, stratified, and cluster. So let's get some quick definitions for those. We don't use them quite as much. Systematic. Systematic has to do with picking a number and do every nth one of those. Now, what does nth mean? Or here it says every kth one. So if I pick the number 5, I can pick every 5th one that goes by, every 5th person that walks past. Or perhaps in the phone book, I could go, okay, I'm just going to take the phone book of all the people that listed that have telephones, and I'm going to call every 20th one. Okay, every 20th. That is systematic. Convenience, of course, is the least reliable, but it's just the data that's easy to get. It's volunteers, or it happens to be everybody that's at a location at the same time. If I want to stand out in front of Walmart and ask people leaving Walmart something, that's just convenient. It's an easy way to ask a lot of people. But it does not really represent the entire population, although it seems like everybody goes to Walmart. That's not a good cross-section. Stratified. Now, the word stratified by itself means layers. So if you subdivide the population into subgroups, which kind of is layers, and then you get a sample from each group. Now, one thing that's a little off on that is that we're really not saying one layer is above a different layer, even though when we talk about the stratification of the Earth, it does have layers above each other. We're just talking about there being different subgroups. So maybe you say, okay, there are some males and there are some females, so we want to get some of each. Or maybe if you're working with a hospital, you want to get administration's input, and then you want to get the nursing staff's input, you want to get the doctor staff's input. And anytime you start to think of subgroups like that, even all the way down to patients, if you're going to get representations from each group, that's stratified. Because that really might not represent the combination of the population. There might be a lot more of one of those groups than another one. So there's going to be a lot more workers than there are administrators. In a cluster sample, it's a little bit more like geography. It's not really geography because it's not a map like that, but it has to do with an area. If you take the population area and you divide it into sections, which kind of think about, maybe you could draw a circle around that particular section. If you could draw a circle around that section and say, okay, we're going to ask everybody in this circle, that's the type of thing to think about with a cluster. But you have to get everybody in that circle. So if you wanted to say, okay, hospitals in Georgia are the group that we're going to look at, and I certainly can't go to all the hospitals in Georgia or everybody at all the hospitals, but you could pick 4 hospitals in Georgia and get information about all the patients at those 4 hospitals at a particular time. That's a cluster. First of all, you still have to define your population. I know there's people in the hospital that aren't patients, but if my population was patients, then I could get all of the patients in that particular place. Okay, systematic has to do with counting, and it's every 5th one, every 20th one, every 1,000th one. That's how you're choosing. Convenient sample, what's handy? What would be easiest for us to do? Stratified sample, we start to think about subgroups and get some from every group. And then a cluster sample is looking at where this stuff is. I want to get everybody here or everybody here and everybody that applies to my population. And a lot of times, honestly, a lot of sampling uses a combination. Like perhaps they want to get a stratified sample and they want to get some people from each group. But then within that group, like if you wanted 5 males, then you might take your list of males and do every 5th one. So that's a combination sort of thing. So a lot of sampling does involve combinations, but right now we just need to recognize which ones were which. Send me and ask my instructor if you have a question on the homework.